Euclid launched in July of last year, and since then we've started to take science data. So we have 6 years yet of a survey of 36% of the sky, so the whole extragalactic sky back in time by 10 billion years. And at the end of that survey, we will have studied at least 8 billion galaxies. We'll have studied the detailed properties of 1.5 billion galaxies to try to understand the nature of dark matter, dark energy, and how they couple together through cosmic history. And that's really 95% of the universe that we don't understand. The other 5% is ordinary matter, stars, galaxies, dust, the atoms that make up humans. And so that's the big questions that we're trying to answer. And what we've done in the last few months is we've started to test our cameras to make sure that the satellite is working exactly the way it should work. And we've shown that we have the most beautiful images, big areas of the sky photographed very quickly, with very good sensitivity, so we can see very faint galaxies very far back in time, and we can do it with crystal clear vision. And so already we've made some new scientific discoveries which will be announced this week at our special Euclid image release, and our scientists have published 10 scientific papers which will be released to the public when we do that release. And just to give you a small sense of some of the early discoveries and really the power of the mission, we've been able to look at some of the oldest building blocks of galaxies. So these are balls of stars that are bound together through the force of gravity. And we've been able to actually study some of those in ways that we've never been able to before from space or from the ground. So it's giving us a taste of the power of this mission for discovery in the future. The images that we're going to publish tomorrow will give us a flavour of the science yet to come in this mission. So the first thing that we're going to show is some of the most massive structures known in the universe called clusters of galaxies. And we'll show how the hidden dark matter influences the nature of space-time, and we'll be able to show how we've traced that. So we look at thousands of galaxies, but we'll also be able to show you some of the stars that have been torn out of those galaxies, and they shine in their own right and produce what we call the intracluster light, so light between the galaxies in this cluster. And that gives us a sense of how the matter is distributed, both the matter that we can see through light and the dark matter, and it starts to give us a taste of where that hidden matter is and how it's clumping together and pulling the other matter together with it. We'll also show that if you are a scientist who care about galaxies, we can study galaxies themselves in great detail, how the stars are forming in those galaxies, and also start to look at how galaxies crash together. So the biggest groups of galaxies are called clusters, but in between we can have smaller groups of galaxies that will then collide with one another. So this is how the universe evolves and how we go from the Big Bang and the tiny little fluctuations at the beginning of the universe through to the kinds of structure that we see today, right down to planets a bit like Jupiter in our own solar system. Well, there are many missions. So in terms of science missions, we currently have 18 missions operating in the sky that covers everything from solar system physics right through to galaxy and cosmology. And we have a number of big missions in preparation. So we will launch the SMILE mission to study the interaction between the sun's solar wind and the Earth's magnetosphere in 2025. We've got the Plato exoplanet mission, which will study Earth-like planets around sun-like stars in 2026. We plan to launch Ariel, which will study the thermal and atmospheric properties of 1,000 exoplanets to actually start to do climate change and atmospheric chemistry on other planets in 2029. And in that same rocket, we will also launch Comet Interceptor, which is a nifty little mission that will fly out, wait for a pristine comet from the edge of the solar system, launch and chase the comet, and launch 2 probes as well. So it's multiple bits of missions. So we've got many missions in the pipeline, and then of course we have Envision, which will go to Venus to study Venus from its upper atmosphere down to the core of the planet in 2031. 2035 we will launch the LISA gravitational wave interferometer, which will be the first time ever humanity has launched a gravitational wave interferometer into space, 3 spacecraft that will be separated by 2.5 million kilometers and will fly together like a perfect instrument, and to actually literally detect the ripples in space-time. And then we hope that in about 2037 we will launch the next big X-ray mission of the 2030s called New Athena, which will then work in concert with missions like ESA. So we've got a very exciting fleet that covers the solar system, other planets, and out into literally the edge of space-time, including Euclid, of course. So it's an exciting time and a very busy time.